Now, while this video won't be an in-depth how to build a Volkswagen motor, I suggest that you check out my friend
Jeremy Docdocil.
He's got a great series on building his motor, and you'll learn a ton of information there. Today we got the short block together on the 1800 build for my 66 Volkswagen Fastback. This won't exactly be an in-depth video, step by step, but just giving you some information as we go along on how we're going about it. We hit the 2 case halves with this Rust-Oleum engine enamel. Good for up to 600 degrees Fahrenheit. So for part of our 1800 build here, we got a CB Performance 74 crank, chromoly piston rods, and we torqued our 12-point hardware to 25 foot-pounds. So we're gonna place in our dowel pins. The dowels allow us to align the bearing and keep it from rotating within the case. So these holes are offset and you wanna make sure to install them towards the flywheel. So we used some Lucas assembly lube. We got it on our bearings. We got it on our center main on the case half.
You'll also notice that on a stock rod, there would be a bump right here. That bump needs to face up. These don't have a bump, but the number faces up. This is the orientation they'll be in when the motor's running, right here. And all 4 numbers face up. So with that being said, we should be able to pick this up and drop it into the case like this. Now the trick is to rotate each one of these bearings until you feel it drop onto the pin. Very important that they align into the pin. It's always a bit of a struggle. You got to rotate these bearings until they drop onto the dowel pins, but when they drop, you'll feel it, you'll know it. Very gently turn your rotating assembly, make sure nothing feels like it's binding or rubbing. And now we can move on to the cam bearings. Okay, here's your cam bearings, and as you can see, there's one pair here. They have sides. These are called thrust surfaces. It keeps your cam from moving back and forth. A lot of the aftermarket ones have 2 that go like this. An original one only had 1 thrust bearing. They looked more like that. But look for your little tang. Look for the notch in the block. Push it in, make sure it's fully seated, and these 2 surfaces should be flush to the touch, and you'll know it's in. This one's going to go in the other half of the case, but moving down the line, there's your center bearing. Again, push it with your thumbs or whatever and make sure it aligns. And here's your rear. I have the lifters now. Again, some assembly lube. Drop them in the motor, hopefully into the lifter bore. Push them all the way in. Put a lot of this on, and then they won't fall out when you're working with the motor. The assembly lube kind of helps hold them in. And also you look and see there's a little hole right there. That's where the oil needs to get through. I try not to put assembly lube in the hole because that's going to restrict the oil from flowing when you first start your motor. It'll have to push that out of the way, and I don't think that's a good idea. Put a little assembly lube on your cam bearings, on each one of the tops of these. We got to look on the crank for the dot. Okay, so there's 2 dots on your crank. They're right here. Let's turn our crank until we come over to here. That dot has to go in between those two dots. How am I doing? Am I in the right space?
Yes, you are.
Okay. Now we can rotate it down. And it should drop right in. Let's see how we did when we rotate it. It's not easy to rotate when everything's all greased up. But if we look right here, the dot on the cam falls right between the two dots on the crank. That's how you know everything's timed correctly. One thing you're going to notice about this camshaft is this is a 4-cylinder engine, but you only have exhaust, intake, intake, exhaust. You would think that would only run 2 cylinders. Well, what happens is the cylinders on this side of the engine are here, and there's 2 more lifters here. So one lobe operates 2 sides of the engine, which is somewhat unusual because most engines have an individual lobe for every valve. You'll need to flip it over to assemble it. And there's a chance these are going to fall out as you tip it over. So one trick you can do is you take a common clothespin and you put it right inside the lifter, right where the push rod goes. Clip it on your finger so the end's down like that. Put it in the hole where the push rod goes. And that'll keep them from falling out when you tip the case over.
Got some gasket cinch, and we're gonna go around the case halves before we mate the two together.
You want to use the proper sealer. A lot of people will grab black RTV, for instance. And what I learned years ago, actually from a Triumph motorcycle dealer, is that when you use RTV, I don't know if you can see it, but you get these little dried up pieces that ooze over into your case. And those little pieces will break off and plug up your oil passages. So no RTV in your motor. If you feel you have to use it, very, very thin coat so there's no squeeze out. Okay, now that we have both sides of the case coated in sealer, I'm going to just take a stick. You can use a dowel rod, you could use a wooden ruler, and I'm just going to try to hold the rods about like that while he drops that case on there. And that's going to help get those rods coming through the windows in the side of the case. Reach in, hold the rod, and drop the case. Should go right down. You gotta get it going straight. There we go. Always start, anytime you torque anything with multiple bolts, always start in the middle using a cross pattern and work your way out. In other words, these bolts will be first, your outer bolts are secondary.
We went ahead and hammered the two case halves closed with a block of wood, just gently, just so when we torque it, we're not drawing the motor together with the hardware, possibly unaligned. But now we're going to go through and we're going to torque all our hardware. So we have our 13 millimeters here. We go around the case and we crank them at 10 foot-pounds and then go back around at 14 foot-pounds. Then you have these larger ones, which are about, what, a 17?
Yep, 17 millimeter
17 millimeter socket. And we're going to do the inner ones first, and then we're going to go to the outers. I just chose to do an X pattern, but we started at 20 foot-pounds, finished off at 25 foot-pounds. Then we put the nut on the crank and just made sure that it spun free, and it's good to go.
For pistons and cylinders, we have these. They're 88 millimeter. And right there is an arrow. Arrow points towards the flywheel when you install them. These are thick wall cylinders. You can see they're actually thicker than a stock cylinder here, which means we have to have heads that are bored for 92. But if you look at the bottom, they're very thin. Doesn't matter. All your combustion's up here. These will slip right into the case with no machining. These pistons have had about a 3/16 of an inch trimmed off the tails here and here, because when they came around, they hit the counterweights of the crank and they needed just a little bit of clearance. Next thing we want to do is, this is just some trial fit here. We're going to take our piston, we'll put it on the connecting rod. I'm putting my finger in here to help line it up. It helps if you don't pull these all the way out, because they are a very tight fit. Okay, normally we'd put clips in here, but this is just a fit up. Arrows pointing towards the flywheel as it should. Now we'll take our cylinder and we'll slip our cylinder over the piston. Drop it into the case. Make sure it's seated all the way to the bottom. And it doesn't hurt to give it a little love tap with a rubber mallet or something. You want to make sure it's all the way down. And we'll rotate the crankshaft now until the piston comes all the way to the top. With my piston all the way to the top, you'll notice it does come just short of reaching the top. This is how you set your compression ratio. You want to be in the 7.5 to 1 compression ratio range. Using a calculator, I found one on Summit Racing. We know that our heads are 60 cc chambers. We know the bore, we know the stroke. You plug all those variables in there and it'll tell you, and that's how you figure out how much you need between the top of the piston and the top of the cylinder. And in our application, we're looking for about 60 thousandths of an inch. That'll get us right at 7.5 to 1. Now, if I don't have, this is not a 60 thousandths feeler gauge. If I don't have enough, what you'll need to do is buy shims and put them between the cylinder and the case. That'll move the cylinder up, making the piston be lower in the bore. Through trial and error, we kept inserting feeler gauges, and we found that the 17 and 18 put together, 35 thousandths, is just about what we want to be. To get to 60 thousandths, we'll put a 25 thousandths shim under here and recheck it. We should have 60 thousandths. That'll give us the correct compression ratio.
Well, here's where we're going to stop for now. We're going to get some shims for this, and then we could finish assembling the long block. And from there, put the coolant tins on it, and it'll be ready to run.